Hello, 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 my fellow YouTubers. Let's go ahead and pop out this video real quick. Jason just posted out a video in regards to east and west in a magnet array, and he was talking in regards to the washing machine motor. That's the stator, and there's the outside rim. And the magnets are usually set up on the inside. I had taken it apart a long time ago to like to take everything apart and see how it works. Let's go ahead and put these magnets back in place, and we'll put the compass up to it, and we'll see what's going on there. We'll help our buddy Jason out. Give a shout out to my boy Jason, my boy Bill, my boy Angel. All my boys out there. So here's a magnet, and that's going to be a North Pole magnet. So we're just going to pick a spot, stick it in there, and then we're looking for a South Pole magnet. There we go. South Pole magnet. Another south. So we got south, north, south. Let's take this off the stand. Let's put it right there so you guys can see it. Obviously all the tools are sticking to the magnets. And I'm going to separate the magnets a little bit. Let's move on to the next one. So the next one is going to be a North Pole. So we have south, north, south. And we're going to put a north. Let's see what the next one is. That's another south. So there's a south, north, south, north, south. Think we can give it a test right now and see if there's a in between, and why would there be in between? Snapping around there. I don't see no west happening. There's a north. North. Looking for a south. Another north. There's a north. North, south, north, south, north. Houston, we got a problem. Compass is good. It's lined up. We got north, south, north, south, north. That ain't happening. Something's wrong. Let's check this up in the air. Ooh, that's a south. It's supposed to be a south. Wait a minute. Somebody playing tricks on me. What's going on here? It says south. Check my compass again. Alright, so take you guys over here. It's my boy Vin Vin. Look how he drinks. Say hi, Vin. Put his whole face in that water. He doesn't go in for slurps, he goes in for glurps. The big gulper. Alright, so that's north that way, and obviously it's heading towards me. so you can see the compass has a flaw. So my advice would be always check out your compass. When in doubt, check it out. How are we going to fix that? Well, this is how we're going to fix it. Got my handy to do neodymium. Bam. I don't care what's north, what's south, doesn't matter to me. And we're going to face this thing towards the north, and we're going to put the magnet in front of it. You can see the north is facing it, right? So if the north is facing it, that really means if this is north or south, which I don't even know yet, don't even know or care, but watch this. I swipe across there, all of a sudden it's heading north. So it goes to show you what a magnet can do. We'll come back over here. Try this again. Jason didn't have this many problems, but I don't think he had his magnets out. So north, south, north, south. We want a north. There's a north. South. Alright, so we want to take this one's a north. That's a south, so north. Holy cannoli. Look what just happened, guys. What is going on? Now you notice I'm lining all these magnets up. They all have ass ends to back ends. Look, look, she's hovering. Oh, daddy. I love magnets. Holy cannoli. Let's get on that. I love finding stuff in the middle of experiments. It's like finding gold. What's going on here, guys? That thing is just sitting there. Look at that crap. Holy crap, you got that array of magnets there. I don't know what pole that is. And then you got the setup that I'm putting over here. North, south, north, south. Then you got this in between it. And I just sat it there and it did that right in front of me. I'm like, wait a minute. You're not supposed to be doing that. What's going on? Yeah, let's see if we start moving this stuff. What's going on? Look, it's going down. Oh yeah, there it is. It's always something. Always finding something. Always something there to remind me. Alright, I'm not a singer. Now that this is over with, the thrill's gone. It's like when you find out what's happening. Alright, let's get back to the study. Enough farting around. That was cool though. That was way cool. Alright. First of all, in magnetism, there is no east and west. I'll just start off with that. So let's go back and check everything. So we got north, south, north, south, north, south, north. So we're looking for a south. Where's your south? Now we're looking for a north. There's a north with a piece of... See, every magnet needs a friend. Remember that. That's my mantra. Every magnet needs a friend. And this magnet happens to be a north. Alright? Every magnet needs a friend. Now we're looking for a south. Nope. And that's a north. And we're looking for south. Feisty little guys. And then we're looking for north. And we're looking for south. And we're looking for north. North. Looking for south. There's your south. There's your north. I don't know. Looks like I'm missing some mags. There's a south. There's a north. South. North. South. North. And with these motors, they come with two different shaped magnets. I noticed this one here that you're looking at, and also there goes one I just found. Also these, and these are cool too. These are bent and shaped, so they go in there, and they're all laid out north south. So I don't think there's anything in between them. Now, let me see if I can find a couple more magnets, because you know what? They need a friend. They're probably stuck to something. Nope. I don't know where they went. So we're just going to call this one all the way around, right? We'll get this one out of the way. See, that's a north. That's a north too. Here's a, let's go to this one. What is this? I don't know. Damn, my compass went back. So you gotta check your compass periodically, guys. You know that wall is facing north. And guess what? It isn't right now. Damn it. So I could have, there you go. I could have facing north now to the north wall. That ain't Ed Leedskalnin's north wall. It's the St. Vinny north wall. It's a good wall. So, that's north. That's south. Let's go back to checking all these and make sure that the last part of these aren't backwards. Just like these magnets are strong. And you can see that they're, if it wasn't for the metal, they wouldn't even stay in place. Let me check the compass one more time. All right. Well, plus the first one we knew was north. So, oh, come on now. I just said we know that one's north, right? It's showing south right now. Let's check the compass again. Where's that wall? Come on. The wall's facing north. It is. You know what it is? Is these magnets are getting stronger and stronger. They don't even want to stay in place. Probably because I have it incomplete with the magnets going around. All right. Now I'm off the floor. Compass back. Let's go ahead and check the compass to the wall. Alright, she's picking up natural streams. There's the north wall. Alright, let's get back to business here. So, south, north, 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 north, south. What just happened? No way, no way. I'm going to say my compass is no good, because you see we started off with a south, which that shouldn't be a south anyway, but I figure I'd roll across here, and by the time we got to over here, my compass already flipped its pole and was no longer reading north. So this compass I'm going to put to the side. This is going to be marked off as a questionable compass. Questionable compass. Always check your equipment over and over and over. I'm not even going to go there. So right now I didn't really plan on doing this video. And my other compass or compasses, which should be multiple ones around here, of course are nowhere to be found as I'm looking. So be patient. There's another compass. Shazam! I got about 4 of these. They were like $2 a piece on the internet. All right, so the north wall. Better angle. There's the true north. The north wall right there. Okay. So back to here. So the first one we start off with right here should be a north. It's reading south. It says south on it. That other compass was crappy, and that says north. All right, we're going to go with this, and let's see if it changes at all. South, north, south, north, south, north, south, north, south, north, south, north, south, nothing, south, north. Wait a minute. Let's check the compass. Compass switched its pole on me. It's not like I'm shaking this thing and it's untweaking itself. I don't know, guys. Leave your comments. This is kind of magnetic mystery. Let's start back off. We know this says south, but on the other compass I started off with a north. So I'm going to stay true to what I wrote on here a long time ago. You can see the S and the N's. Now it says north, south, 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 north, 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 north. Seriously. Seriously, 17 minutes here, and I was trying to do a 2-minute video. Are you freaking kidding me? So we're going to unarray the magnet, and we're going to see it says north, and there's an N on it, okay? So let's go ahead. We knew we started over here, and it said north, right? And it says north right now. So let's this is called process of elimination. This is how I do my experiments, especially when they get wacky like they are right now. So I pulled it away from the metal and from the other magnets. And it said it was a north. It still says it's a north. Let's go over here to the... Well, I can't do that. It's still saying it's north. And then that's saying south. So I'm going to take a guess that the compass can't be right again. And it's facing the north wall. That is crazy. Hey, I don't like making videos like this because this is stuff that I like to do on my own, and I feel a little pressured right now because I was expecting the results on the east and west with the north and south, and that was a beautiful video that my friend Jason made. But I wanted to go deeper in detail because I know a little bit more about it. But all of a sudden now I'm throwing a curveball in regards to the compass is saying north when we know it's a south. It's ridiculous. So let's work the compass over and see if the compass switches itself. Here's a north, south, north, south, north, south, north, south, north, south, north, south, north, south. Well, that one goes to nothing. This could be why Jason's experiencing sort of a, if you want to call it east or west or something, but there's really no magnetic streams running east or west, all running north and south. But in between the ribs We'll call them the meridian lines, or I call them ribs from north to south. They're thick streams. In between is like little fingers, little static that fills the area, but it isn't static because it's moving. So let's go back to why is this. Look, now it says south, so it switched over the compass. And the compass now is still reading true north. So the compass is still accurate. Answer the question, guys. What happens when you start putting these magnets in an array? What is going on? Well, if I was an educated man, which I'm not, I would say what? I would say give me a pencil and let me draw it out. If I could find me a damn pencil. Here, pencil, 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 pencil. Gotta call the pencil like the dog, right? That ain't gonna work. Alrighty. You gotta be kidding me. Kidding me. Stay put. Glad to see you guys made it back. Everybody busy, Vinny? All right, I'm back. I go snatch something. So in regards to the wheel, this being the wheel, and your magnets, and in regards to up here being North Pole, South Pole, and that's East Pole and that's West Pole, that your field lines there's a twist to them or bend to them because of the curvature, and in between, hell, I thought you guys were looking at that. Here's the wheel. But here's also the planet. Here's your North Pole, South Pole, West Pole, East Pole. Here's your field lines, the magnetic fields coming from the North Pole and South Pole. Now, at 90 degrees from the field lines here is the verticals going straight down. That's where your static and your electrostatics fill in between these magnetic lines. But they're going straight down. So that means if you were looking straight ahead of you, there would be a dot, what I would call matrix, that's straight in front of you, and any pressure will push that dot up, that dot up, that dot up, and that dot up. Any pressure from a lower pressure or a higher pressure, and that pressure shapes, so you guys can see it shapes to where you put your lines together, and that's how you get a wave. So your wave is, if you look straight out from your eyeballs, everything is a dot matrix, and then the wave is formulated by these pressures. You got high pressure and low pressure. Now on here, you got your meridian lines, and then you got your electrostatics in between. The electrostatics in between are shooting 90 degrees off from the magnetic field lines, because everybody talks about the magnetic field lines because gravity pulls. Well, it pulls, but in order for it to pull, there's got to be electrostatics, and electrostatics is where you see lightning running horizontal or vertical, not so much horizontal, more so up or above the clouds, horizontal, and a vertical in the lower area. So what I'm getting at is, for some reason, these magnets, when you put one that's a north and one next to it is a south and the next one's a north, and they're all touching, okay, something's going on, because the back side of this magnet, can you guys see that? The back side of that magnet is another pole. That's why there's a dipole there. I want you guys to know that. There's a dipole. So if this was a cube, okay, and these were all cubes, it'd be easier to visualize, and that's why I'm going to make them cubes, because there's a depth to each one of these magnets. Even though they're rounded off and tapered on the end, there's a depth. That's about 1/4 inch. So if that's a north, there's your dipole. This side's a south. This side's a north. This side's a south. This side's a north. This side's a south. But what's going on in this whole array of magnets is you're distorting the field lines. So if your pole, North Pole and South Pole, are here and your field lines are running from those two strong pole ends, you're going to have the same thing going here. Okay? And then all of a sudden, you're encroaching this field into this field. Now this one is doing the same. Now do you see what's going on here, guys? You're having field lines that are starting to go into the other magnets. So the compass, which is saying north and south. The other one, that compass was reading wrong when I brought it back to the north wall. It was telling us that it was confused because it didn't know what to tell us. It really couldn't. It's hard to tell because all the field lines are meshed together here. You still have your north here, your south here, your north here, your south here, your north here, but you also have all the lines are overlapping. So what happens to magnets when the lines overlap? Leave your comments. I'm leaving the rest up to you guys to use your brain. Get those noodles working. Hopefully you enjoyed my blundering through this. It's supposed to be a 2-minute video, but actually this is what I do behind the scenes. And I dig in deep, and I want to know why, where, how, when. When you seen that little magnet that looked like it was levitating, you know, all of a sudden out of nowhere, it's standing up for me. Was it the magnets here? Was it the iron? Or was it the magnets over here? We found out it was the magnets over here by starting process of elimination. So if you guys don't do process of elimination in your workshops, my advice is to always question everything. Even when you want it to be the results that you were expecting, question it. Peace out, my bro hams.